Take a look at your device you're watching this video with. What do you see? You see a phone, or a laptop, or a tablet, or whatever you're using. But what if I told you that device could be a box, or a battery, or a baseball, or anything except what it is now? Well, that's basically what the Copenhagen interpretation of quantum mechanics is all about. But to first understand what the Copenhagen interpretation of quantum mechanics is, we must first understand what's quantum mechanics. Quantum mechanics is the branch of physics that studies the behavior of atoms and subatomic particles. In other words, quantum mechanics is a study of the very, very, very small. It's the study of the behavior of these atoms and subatomic particles. It's a study of what they do, how they do it, and why they do it. Now that we have a basic understanding of what quantum mechanics is, let's delve into the Copenhagen interpretation of quantum mechanics. Conceived by renowned physicist Niels Bohr in 1920, the Copenhagen interpretation is an explanation of the mysterious behavior of quantum particles. What is this mysterious behavior? Let's take a look at the double slit experiment. The double slit experiment is a demonstration of the wave-like property and the mysterious behavior of quantum particles. In the double slit experiment, scientists fired electrons through two slits and at a barrier. So let's see what happens when we throw this ball through this slit, and the barrier in the middle. The cool part is that when scientists fired electrons through these slits, they discovered these electrons landed everywhere, regardless of which slit they were sent through. So scientists found that electrons have wave-like properties. They move and behave like waves. So when an electron is fired through this slit, it moves like a wave. If it's fired through this slit, it moves like a wave. And it can hit this part, it can hit this part, it can hit anywhere because it moves like a wave. It has wave-like properties. Here's the mysterious part of quantum mechanics. These electrons only move and behave like this when they are not being observed. When electrons are being observed, they move in a straight path. That's the mysterious part of quantum mechanics. That consciousness and observations are an integral aspect of quantum mechanics, of how these subatomic particles behave. For example, if a tree falls in the woods and no one is there to hear it, did it make sound? Here's the crazy part. The Copenhagen theory behind all this states that these wave-like properties of these subatomic particles are actually waves of probability. And the act of observing these particles collapses all these waves of probability into one wave of probability. Like when observing an electron being fired through two slits and at a barrier in the double slit experiment causes the electron to hit only one possible location of the wall behind. So really, this basketball could be a battery or a box.